Hello, my name is Daniel Moreno, and my partner is Magali Vargas, and we'll be discussing the relationship between skin fold thickness measurements and body fat percentage in youth. Assessing body composition is essential for understanding health and fitness status. Body fat percentage is commonly estimated using skin fold measurements, with tricep skin fold thickness serving as an indicator of subcutaneous fat and overall body fatness in an individual, as it was stated in Yang's article in 2024. This study examines the relationship between tricep skin fold thickness and overall body fat percentage derived from skin fold assessments. For the first group data, we looked at the relationship between tricep skin fold thickness in millimeters and body fat percentage. We hypothesized that there will be a significant relationship between tricep skin fold thickness and body fat percentage. The second group, we looked at differences in abdominal skin fold thickness in millimeter between males and females. We hypothesized that males will have higher abdominal skin fold thickness than females. Lastly, we looked at the body fat percentage across different height groups. We hypothesized that there will be a significant difference in body fat percentage among short, average, and tall height groups. The purpose of our study is to examine how skin fold measurements relates to body fat percentage and why their body composition differs based on sex and height in youth participants. Why does this matter? The study matters to help the youth better understand why their health and fitness is important. It's also beneficial for coaches to monitor their youth group's fitness progress. The study will help PE teachers and trainers when they'll be working with these youth students. It can also assist health professionals during these growth assessments. We'll be able to discuss how the tricep skin fold may help estimate body fat percentage, and this is to help the youth to make better decisions when it comes to their fitness and health. The methods that were used were the tricep and abdominal skin fold measurements, and the tool was called the caliper. This was to measure the thickness of the abdominal and tricep sites during the skin fold assessment. Body fat percentage was also calculated by using the skin fold equations. As for the analysis, we determined the differences between the three different groups by using Pearson correlation, t-test, and one-way ANOVA. Participant characteristics consisted of 45 youth participants, which included 23 females and 22 males. Participants had a mean age of 11.06 years with standard deviation of 2.12. And the age ranged from 7 to 14 years old. Participants were categorized into three height groups. Short was defined as less than 140 centimeters. Average was between 140 and 155 centimeters. And tall was greater than 155 centimeters. Overall, the mean height of the sample was 144.3 centimeters with a standard deviation of 12.53. The mean body weight was 40.82 kilograms with a standard deviation of 11.09 kilograms.
We analyzed our data for tricep skin fold thickness and body fat percentage using Pearson correlation, and the results showed that we ended up having a strong positive relationship that had a correlation value of 0.787, which meant that as tricep skin fold thickness increased, so did body fat increase. This can be clearly seen in our graph, where we have an upward trend rather than the dots being scattered all over. The average body fat percentage in our sample was 5.99% with a standard deviation of 5.33%. This showed some variation between individuals, but as you can see, we still got a clear overall pattern. This suggests that tricep skin fold thickness is a good indicator for overall body fat in this group. So These results do actually support our hypothesis. When we got the difference in abdominal skin fold thickness between males and females, we used an independent sample t-test, and we were able to see that there was no meaningful difference between the groups. We had a t-value of 0.825 and a p-value of 0.414, which meant that any difference between males and females would not be strong enough to be considered meaningful. Even though females did have a slightly higher average abdominal skin fold thickness, the difference was small, and the graph shows this clearly, as the values of both groups overlap a lot instead of actually being separated. The standard deviation of 7.4 millimeters shows a wide spread of values, which actually explains why the groups look so similar, but this does not support our hypothesis, since we did expect a difference between males and females. When we looked at our data for body fat percentages across height groups, which is short, average, and tall individuals, we used a one-way ANOVA test to compare all three groups. The results ended up showing no significant difference, with an F value of 0.836 and a P value of 0.44. This indicates that body fat percentage does not meaningfully change based on your height group in this specific sample. The graph supports this. As you can see, all three height groups show very similar average body fat percentages with no actual clear separation. The overall mean was 5.99% with a standard deviation of 5.33%, showing variation within groups, but not between them. This suggests that height is not a strong factor in predicting body fat percentage. This result does not support our hypothesis because we did expect there to be a difference between height groups. Let's take a moment to discuss our research. So for the first one, we had tricep skin fold thickness and body fat percentage study, which we were able to see a strong positive relationship. That really just meant that when tricep skin fold thickness increased, body fat percentage also increased, which we were able to see because we had a clear upward pattern in the graph. And as for the abdominal skin fold thickness comparison between females and males, we saw that there was actually no meaningful difference between the two groups, and so the graph showed overlapping results with no actual clear separation. And our last study, which was body fat percentage across height groups, we also saw that there was no meaningful difference between the groups. This meant that height doesn't appear to have a clear effect on body fat percentages in this specific sample. The graph reflects this by showing similar values all across all height groups. Overall, the only relationship that we did see was the relationship between tricep skin fold thickness and body fat percentage, while the comparisons for sex and height did not show any meaningful differences. So in conclusion, with our study, we were able to see that tricep skin fold thickness was the strongest indicator of body fat percentages in this specific study. Higher tricep skin fold values were linked to higher body fat percentages, showing it is a strong predictor of body composition. However, sex didn't significantly affect abdominal skin fold thickness, and height didn't significantly affect body fat percentages. All of that just suggests that grouping individuals by sex or height is a lot less useful than looking at individual measurements. Overall, skin fold measurements may be a simple and practical tool for assessing body composition in young people. This knowledge can all be useful to coaches, PE teachers, and health professionals when we are monitoring growth, fitness, and health.
And these are the list of references that we used for our study.
That's the end of our presentation. I hope you guys all took something away from our research and our data. But thank you very much for listening, and I hope you all have a great day.